Hello and welcome to today's event. The topic is how to modernize your virtualization stack. This is a hot topic because so many companies out there are struggling with management challenges around their virtualization and cloud native applications. And on today's event, you'll learn about a solution that can help you to overcome those challenges. And even better, you'll see it in action with a demo. So I'm super excited to see this solution for myself, and I think you're going to be really impressed. Now, my name is David Davis of Actual Tech Media, and I'm glad to be serving as the host and moderator for the event today. And I want to give a special thanks, of course, to our friends at Platform 9 for making this event possible. Before we get started, I want to give a special introduction to Mr. Chris Paap. He is a pre-sales engineer at Platform 9. He's been in the industry 20 plus years, working as an IT practitioner, focusing on enterprise infrastructure. And he has a lot of experience in product management and pre-sales, helping customers to modernize their hybrid cloud and cloud native infrastructures. Over the last 9 years, Chris has worked on various initiatives around enabling customers to implement database as a service and moving forward into Kubernetes. Chris, it's great to have you on the event. Thanks for being here.
I'm glad to be here. Thank you. Thanks for that great introduction.
Absolutely, yeah. So, let's go ahead and kick off today's event. Chris, why don't you tell us about, Platform 9 and what it can do to help companies overcome these kind of management and virtualization challenges?
Yeah, absolutely. I mean, the title says it all: modernizing the virtualization stack, um, and it's something that we're constantly doing from an enterprise perspective. And it's not easy to do, and we're going to talk about that and how we help solve that through our offerings, and what are the challenges to get in there, and how we can help get you there. Um, First of all, when we jump into it, kind of speaking to it, when you're modernizing an enterprise environment, it's not easy to do, right? There's three laws that kind of follow that. It's not easy because you have the law of economics, law of physics, and kind of the law of the land, and it's kind of mixed in with like where it comes in with the legacy applications and expertise in your environment, and that kind of law of economics of OpEx costs. And this is why I say that. When you're trying to do any type of move or any type of modernization, um, at the same time, you're trying to workloads that are in progress, that are like production workloads, whether it be tier one, tier two, tier three. Um, it takes time. It's time consuming to migrate those to a modern environment. In our case, if you're trying to move it from whether that's a legacy application that was built in house, or it is an application that is no longer available, but it's very critical to the company. So it's just very old. So it's probably, it could be that box sitting under somebody's desk, right? That just running under a developer's desk. But when it goes down, the whole company knows about it because some ETL process doesn't run. Um, or it could be something, like I said, that was built very specific, customized, bespoke to the company, that wasn't a third party app. Or when you're trying to move those things, you have it's complexity, or you have added complexity of how do you then, if you're going to go cloud native, as most companies are doing now, how do you decompose those? How do you break those applications down in containers and still keep everything up and running, right? Um, there's the kind of the law of physics when you're trying to modernize too. So more and more, the edge is playing out, right? You need that. You need your compute and resources right now where the data is, where it's happening, whether that be retail, telecom is big, right? So that determines, well, how do you get those out to multiple hundreds, even thousands of locations versus just a centralized data center? How are you going to do that? And then the law of economics, or OpEx costs and licensing costs, come in. Why are you doing in modernizing? Sometimes, a lot of times, it's two separate infrastructures that you have set up, two separate application stacks, two management stacks. Now your IT needs to take care of, and so your licensing cost doubles, your time to resolution doubles, so it takes longer to spin things up and spin them down, and that ties right into the expertise area. So now we already ask a lot of the IT department, right, and the application teams that make those up. Now we're asking them to do even more of learning maybe two different technologies and run it on two separate platforms and be experts in each. And oh yeah, we need five nines, right? So we need to always keep the environment up, like no mistakes. And so if you're adding more to the environment, the complexity gets more. And kind of the rule of law is like when you add more complexity, more bad things will happen. Generally. So those are the kind of, that's why, it's not a trivial task to modernize. It's not a decision that's taken lightly by enterprises. Um, but what drives them, right? Like if it seems so hard, I kind of painted this kind of very, you know, it's not even, we have a picture of the mountain, that last slide. It's a vertical slope to some when you think about all the complexities and the obstacles in front of them. But there's a lot of necessity driving that. Like, why modernize? What is the benefit of doing that? Again, the reason is the necessity to keep applications up and running, right? The need for performance as these legacy applications age, or the underlying hardware ages, or how you're managing, or the need to scale that out, especially in today's kind of cloud-based deployments. How are you going to do that, right? If you have this monolithic application, it takes much longer to spin up, and then to then keep that highly available. That takes a lot of time and effort. So that's kind of pushing it. The cost that's associated with that, right? All the additional licensing that's associated to keep the environment up. There's a push to go open source. There's a lot of shock when it comes down to, when you have now this sprawling environment, you have duplication of licenses, and the license is very expensive, and now the customer's locked in. We see that in just traditional applications, but we also see that with a lot of the pushback. There's a lot of communication going on when I talk to customers where they went all hyperscaler cloud. Now they're looking at pulling some of those resources back onto on premises because it's gotten so expensive, right? Like it did a good job. They were able to scale up when they needed to. They had unlimited resources, but it's just not tenable for a long-term goal. So based on like if that data needs to stay close, or if they can run it cheaper on premises and then take care of that with open source, they save on licensing costs, right? But how do they do it? And with that, the other thing that's driving is like the whole self-services with developers and being able to deploy those out. Again, uh, application IT resources are finite. So if you can offload that and you can give a developer the ability to do full lifecycle management of their environment, spin up when they need that, and the applications that they need when they need it, not have to wait a week. Sometimes I've talked to customers where it takes 3 weeks to get something spun up. At that point, they were hoping to be done with the project. Uh, how do they take care of that? So they're trying to streamline that process and reduce the delays, because if they can do that, there's a direct improvement on the line of business, and that has an impact on the bottom line, right? If you're able to get things out faster, more revenue is generated for that company. It's just generally good. Or the other thing is true, better product comes out. If you're developing, you're able to iterate quicker and not wait to the end and it takes longer. You're able to do something in a day where before it took a week. Better things come out of that. So those are just huge pillars, right? Cost and efficiency and scalability. So the way people generally turn about, I've been talking about kind of migrating, just kind of eluding the fact of migrating to the hyperscalers and public cloud. It's fine. There's benefit in that altogether. You have the scalability and the resource wealth that's out there. But on the other hand, as you start scaling out, it gets very expensive, and that sticker shock comes in of paying that those renewals every month or every year as it comes into place. So like that's not one size fit all, right? The fact that you need resources on-prem or on the edge, right? That what ends up happening there is a DIY problem. DIY is very hard. It's very complex. You have to build the expertise in that. And there's a need for support in all those different components. So what happens when something breaks? Or as I said, like when something goes bump in the night, who are you going to call at that point to help you out? Do you have support contracts for all those different components that you built DIY? And then who else besides like that single point of contact is going to support that? Is a whole team going to scale up? Or can you hire enough people that have that expertise that run that environment, right? So you have those two options. Platform 9 is, we like to position ourselves as that third option to have, where you get the best of both worlds. Kind of that, like not too hot, not too cold type of feel. You have the benefits of running the environment wherever you want it, whether that's on the edge, on the public cloud, and you have the capabilities of SaaS management. So you just run everything from a central control plane. wherever you want to run it, and you have that availability, scalability um, as you need it. And then on top of that, you have 24/7 support for all those components. So if something does break or troubles arise, we're already on top of it, helping you solve that and getting it up much faster. So let's talk about the problems, um, why people are still moving and trying to modernize their applications and their infrastructure, and how Platform Nine is that third option between on-prem, DIY, and public cloud. Like, where do we fit, and what exactly do we do? We're known primarily for Kubernetes, but we do virtualization. So if you look at the bottom of this slide, everything at the bottom is, anywhere you want deployment, whether that's virtualization or Kubernetes. Um, we run production ready Kubernetes that's supported and virtualization wherever you want it. We provide bare metal as a service. So if you're deploying that on-prem, you can deploy Platform 9 on top of a bare metal OS or VM that you just provide the OS for, and then we deploy Kubernetes and virtualization on top of that. And so this way, if you're running a virtualization cluster, you provide the hardware for it. Then we deploy Platform 9 on top of that, and we can deploy a cluster. So then you can run your VMs and applications on top of that. And then as you start going cloud native, you have that same management plane, that same infrastructure you can be running containers side by side with that as you start migrating into that new path. So it's like not an all or nothing approach. And then on top of that, as part of Platform 9, we provide the infrastructure services that are on top of that, whether that's like the networking, the load balancing, uh, the observability stack, such as like Prometheus, FluentBit is part of that to kind of export out those logs, and then Grafana to kind of show that time series information. And then kind of encapsulating all that is an easy to use UI, right? You can get as technical and as advanced as you want with the CLI. It's fully supported. But we also want to make it very easy. We want you to be able to, as an end user, focus on the applications you're trying to deploy and get out and keeping everything up and running and not having to be an expert in just Platform 9. And so easily spinning up VMs in an environment or deploying a container, easy to use UI. It's very intuitive. Walk it through in kind of a single pane of glass to do all your different day zero to day two operations within that, without having to learn two different stacks to run virtualization and Kubernetes.
Hey, Chris, sorry to interrupt, but looking at that architecture slide there, I think that gives us a great visualization of how this works. I mean, Platform 9 is traditionally known for managing Kubernetes workloads. So that begs the question to me, is what we're talking about here with KubeVirt, is this Kubernetes or is this virtualization?
It's an excellent question. It's a question that comes up quite a bit. So um, KubeVirt is virtualization. It's actually, when we dive into a little bit more, I'll show you, but it's KVM is the underlying architecture. It's just what KubeVirt allows it to do is now run underneath Kubernetes. So Kubernetes is the orchestrator for that virtualization, for that hypervisor that's running. So all the functionality that you have today with your traditional virtualization environment, you have that with KubeVirt. So you're able to run them. The benefit of that is they're running side by side, right? Without having separate infrastructure for both.
Very cool, which has traditionally been a challenge for a lot of companies. They can either run virtualization or Kubernetes, and they're trying to decide between one or the other. And here, this sounds like you said, the best of both worlds. And I also like there at the bottom how it looks like we can do this pretty much anywhere on our own hardware. We can do it at the edge. We can do it in the cloud. No matter where these virtualization or Kubernetes workloads are running, Platform 9 can help us to manage them. Is that right?
That's correct. Absolutely correct. We want you to be able to run your environment, and it's your choice, right? It's your option. It's not an all or nothing approach, especially in this kind of hybrid world we're living in.
Nice, nice. Well, I'm excited to learn more about KubeVirt.
Yeah, absolutely. Um, let's jump right into it then. That was a great segue into that. I guess the question that you kind of led with a great question, like what is KubeVirt, or like better question too is like why should you even care? So kind of touching on that in the simplest form, KubeVirt allows you to run VMs in a single stack infrastructure side by side with containers. It uses KVM underneath it. You use the same tool sets for both. So it's the same management interface, whether that's from the UI, you're managing all that from a central control plane, both your containers and your VMs in your environment. That's for monitoring and operations. So it reduces the need to have like traditionally that separate stack I talked about earlier, just a few slides ago, of having a stack for virtualization and a stack for cloud native. And then even between like that virtualization, you might actually have two different stacks of like of vendors, right? If you had open source and then say, for instance, VMware, which we've seen in some environments based on the workload. So now they have two stacks, virtualization and cloud native, and then within the virtualization stack, they have two different vendors. So another interface they have to manage and work with orchestration with to get that through. So as a company is trying to go cloud native, the biggest barrier is like, how do you take a very complex tier one application and migrate that over into Kubernetes? And reduce downtime, make sure you get it out to market fast, and make sure it scales to meet all your availability goals. So KubeVirt, because you can run VMs inside Kubernetes, gives you that kind of step approach. It's a very pragmatic way of going to cloud native. Even if you're at the very beginning stages, you can still run on VMs where you're comfortable, where your expertise is, and especially if you come from a very UI-based environment, like a VMware environment, a lot of those daily operations are very easy to do within KubeVirt. So you still have that. Or what you'll run into as well is as you start taking an application set and all those different components of an application set, some of those components may be containerized. Well, other ones, like say the database, will still be a VM for a while, and they can all live together still in that single stack and communicate without having to break that up. And it gives those application teams time to do that and to decompose those applications completely. So again, leading on to the fact, like, why should you care? What are the benefits? What do you get out of it? So a lot of the questions I get when somebody's brand new, they've never heard of KubeVirt is, can it handle my tier one applications? Because they're concerned about performance and availability. Kind of leading on to that, like we're from the availability and, is it baked in enough and prime time ready? Leaning on the fact that it was based on KVM, right, under the covers. KVM runs the entire internet. Like that is the most adopted hypervisor in the world. So hyperscalers are running it. And with that, those capabilities inside KubeVirt, they've also built on top of those, like for high performance needs, whether that's some of the advanced pass-through capabilities. Say, for instance, you are doing like AI or ML type of workloads, data mining workloads, and you need GPU processing on a VM. We can provide that, or we can do things like CPU pinning, where we make sure that it's going to have a dedicated processor, multiple processors or threads or sockets that are available to that VM. Any of those very deep, unique capabilities are available to KubeVirt. The fact that you can manage it and scale it out within Kubernetes and grow it leads to kind of that ops efficiency in terms of cost. And that you can manage it as a kind of a unified infrastructure saves on both time for your team, and so there's like that the cost associated where like you no longer have to deal with two different infrastructures and manage that. And then there's the licensing cost, where now you don't have two different stacks to pay for. You're kind of just managing it all with one and get that support. So you have that availability. It's just built in with the product, and you're reducing the complexity overall, right, in the entire environment. So you're simplifying it, both from a day-to-day standpoint, but just from what's residing in your infrastructure. So just this is a diagram of just kind of a 10,000 foot overview, right, of where KubeVirt sits within the overall Platform 9. So the image on the right is basically how if you have our platform and it is SaaS managed, so the box in the upper top right, that's the centralized control plane that lives in the cloud. As a customer, you're coming in, you can log in via the GUI or API based. You're able to get in and you get access to like the deployments, the monitoring, the diagnostics, and then That's what lives in the cloud. You have availability. You don't have to worry about those things, all those add-ons. We take care of it and we monitor it. Whether you deploy in the public cloud, as on the right, or you're deploying on premises, we're able to connect back to that in central control plane via 443. You deploy where you want, and we're able to communicate and manage and do the lifecycle management in that environment. So when KubeVirt is deployed, if you're looking over the left, let's say you're deploying it on the edge, you're deploying it on bare metal. The bare metal, you might put CentOS, Ubuntu, RHEL on that. And then we deploy Platform 9. And when the Platform 9 is deployed on top of that, that's where you get the ability to add KubeVirt. So Kubernetes is the base. Kubernetes cluster is deployed on that environment. And then on that cluster, KubeVirt is enabled, which in essence turns it into a virtualization cluster. KubeVirt then can spin up virtualization machines and keep them persistent, so the data resides in there. And every virtual machine that it spins up, it encapsulates in a pod. So that VM is sitting within a pod, sitting in Kubernetes. So that's how it's able, and it's not a separate infrastructure. That VM is actually running inside Kubernetes. It's not side by side with Kubernetes like a sidecar. It's actually within Kubernetes. That VM, each VM persistent VM instance that's coming up is has its own pod associated with it. Well, how do we get there? So if you're coming into KubeVirt, essentially, like if you're, whether that's OpenStack or VMware, we can simply take those kind of that format, export it out, ingest it into KubeVirt, and turn it into a VM. Right, and that VM is broken out. Every one of those pods is that kind of Virt launcher pod, that box that you see up there, and that's kind of managing both of those. And you have those sitting on like node 1 or node 2, or to use a Kubernetes kind of terminology, that host 1, host 2 is actually a worker node in the environment. That's kind of where you can migrate and live migrate. So you have that high availability that you still had with VMware. You have the ability to vMotion over. It's called live migration. If one node goes down because of maintenance, or host goes down because of maintenance or unexpected an outage in the environment, those workloads will migrate over and be on the next host and node. So you have these capabilities of scalability. You can add an additional node in the environment as resources start to get consumed. You're growing more and more VMs in the environment, and the resiliency of the environment. You can lose one or take it down for maintenance, and still have your environment up and running. And that's how the things on the left come through. So based on that, that's how you get access to hardware pass through. You can set it in maintenance mode. If you're doing a cluster upgrade, like our whole point is not to interrupt that application. So the way we don't interrupt that application and keep it serving the end users is to keep that VM up and running. So if there is a cluster upgrade, which we help perform very easily, we support you on that through the GUI, through command line. All the VMs in that host or node will then migrate over automatically as you're doing a migration. So we don't take, if we're doing a full cluster upgrade, obviously we don't take that whole environment down. It'll be one node at a time as it migrates over, and that node comes up and those workloads move over to that available node. So I've talked quite a bit about it. I'd like to at this point kind of move over and show like a quick demo and kind of look and feel of what it's like to manage a KubeVirt environment and kind of spin up a VM in real time in that environment.
Yeah, this is really cool, Chris. I mean, I love the idea of bringing the benefits of Kubernetes, like massive scalability, high availability, resiliency, bringing those to virtualization by bringing virtualization into Kubernetes. So this is cool. I'm excited to see KubeVirt in action via Platform 9. Take it away.
All right, so this is the control plane that we're looking at right now. Simple login. It's a URL that's unique to your enterprise. There's no shared resources. It's all isolated. There's no shared networking. This is the control plane where you're going to manage all your environment, whether that's the infrastructure, the Kubernetes portion, or KubeVirt. We have an application picker at the top that you just select, and you can scroll down. If you select infrastructure, this is where you create your clusters and you add your nodes. In this environment, we already have a pre-made cluster, 3 physical nodes that are in here. And that from an add-on perspective, we've already enabled KubeVirt, and we're running version 5.8 at this time. You can also see as an add-on, we have our monitoring, or Prometheus monitoring, that we get all our metrics from. We choose infrastructure. We go into Qvert. We're bringing you to a dashboard that gives you kind of that overall health and view of the environment. It's from a cluster health, node health, or we call them hosts, and the virtual machine environment. This Qvert status is the status of that add-on I pointed to that's enabled on each cluster. So to reiterate, Qvert is enabled per cluster, and in this node we have a 3-node cluster. So if we had 10 different clusters in our environment, and Qvert was all of them, we'd show 10 different instances in that environment of how that add-on status is doing. So as we scroll down here and click on virtual machines, this is where you see like your entire virtual machine environment, and then you can do all your day-to-day operations from here. If we go into, say, let's go into this test environment, this VM called test. This is where you're going to have all your management applications across the top, all your kind of things that you do on a regular basis, whether that's restarting, stop, pause, migrating. This migrate VM is where you'd actually migrate the VM to a new instance. If you wanted to delete the VM, this is where it happened. This is where you see where your resources are set, the amount of CPUs. You can notice that we have this broken out by like CPU pinning, the amount of memory dedicated to that. The host it lives on is over here on the left, along with the cluster. So this is very important. So if you have multiple clusters in your environment, you can select in the upper right the cluster that you want to look at. Right now we just have this individual cluster selected, but if you had multiple clusters and you weren't sure which one you were in at the time, this is where it would give you the information. This is where it's going to show you the VM status that's running. And very important in terms of context, this here is like the pod it's running on. If you recall earlier in the slide deck, I talked about every time a VM is spun up in Qvert, it runs inside a pod inside Kubernetes. So if we click on this, it'll take you to that pod and show you all the resources that it's on, the cluster, the quality of service that it's set to, how old it is, the containers that are associated with it, as well as the services. So all contextual information in the environment. If this pod had some ingress information, it's shown here. Since it is a VM that we want that data to retain and be persistent, it does have persistent disks associated with it. So it'll show you these. If this had multiple disks, it'd show you all the different disks that are associated with this pod that's attached to the VM. So in other words, if you restart, all your data is going to be there as you would expect. Here's the disk information. It has information of where it's coming from, the source, the access mode. Very important. Just a quick note. There's a couple of requirements to live migrate. One of which is to have your disks, if you have persistent disks associated with this VM, to have it as read-write menu. So it just gives you the ability to move that around in the storage. If you have read-write once, or read-write only, then that means that's one of the things that when you go to migrate, it won't allow you to. You'd have to shut the machine off and then migrate it that way. Any tags or annotations, this is very nice to have. If you spin up a VM and you add a label, or in kind of virtualization speak, that label is a tag. So if you're associating with backups or just identification or notes, or the simple who it belongs to, you can set that up here. You can modify it and create your label. Let's go out. If actually, as you go in here, is other things as your VM needs more resources. If you hit that edit button, this is where you're able to, since this is part of an instance type, I wanted to show this. An instance type is, think of it as a template in Qvert. So if you have, it's a way to set like, I want to have a large VM be 2 vCPU and 4 gigs of memory. So you just select that template and it automatically selects those resources for you. And then if you wanted to make it smaller, you could, or you could create new different types of instances. Say you just had a DevOps instance for the DevOps team that they always get 16 gigs of RAM and 4 CPU. And then you could set that for the scope of the namespace or the cluster that they have access to. So they'll only see that instance type. Another way that we can do that is if we go to this resource here and we click edit. Now you can manually choose it, like how many cores you want, how much memory. You select on advanced options. This is where you can set request for memory limits. It's kind of it is associated with the VM, but it's using a Kubernetes terminology. So if you always want to create requests and limits the same, so this VM is always going to get 8 gigs of RAM in the environment. Think of it almost like a quality service, like it's always going to have access to those resources. You could set that here. If you wanted to set CPU pinning, you'd enable that CPU pinning switch, and then you could set it up how many sockets you want dedicated to cores and threads that it'll always have access to in the environment. And so this is where you kind of do your hardware pass through and CPU pinning for that. Another thing I want to show, so you can create the VM from the UI, or if you want to look at what the manifest looks like, or it's a YAML file in what that looks as text, so you can copy and download this out. If you wanted to script it out to create a bunch of VMs at one time, you can save this and kind of modify it and then script that out to deploy later. If we wanted to, for instance, live migrate this VM, let's migrate. We have a dashboard for live migrations as well. So it'll show up here. So this is very handy if you're doing, say you have 30, 40 VMs on a host and you need to bring it down for maintenance. It only does so many at a time. You can see the status of it. So as it's doing, the first 4 or 5, the rest are pending, and as they complete, either shows up as succeeded, or as you see this one, we have set up that it failed. And so you can go back and then manually migrate that over or resolve the problem that's keeping it from live migrating. And then on the side here, you also have the different types of instance types. You create a new instance type. Only thing required is a name, the cluster, the namespace, so where it's going to be assigned to, and the amount of resources you want to add to that. So if you want this to be, 4 vCPU and 4 gigs of memory, you can set it up that way, save it, and then based on the cluster that you want this assigned to, only that cluster will see that, or the namespace. Again, we talked kind of the dev, having the dev team have their own instance type as a use case. If they work on this cluster and it's only them, you can set this up for an instance type that only they can see and have role-based access control, allow them just to work on that or that particular namespace. So to add a new virtual machine environment, go to all VMs, add virtual machine. Only requirement, give it a name, pick the cluster, the namespace, by default, and the type. You can also create it by YAML, like I showed earlier, that when you downloaded it, you can copy and paste it there. You can also select that box and do multiple VMs at one time. Select next. This is the access mode I talked to. You read write once. If we want it to live migrate, read write many. You can set the storage size. If you have a storage class, like in terms of if you have one created based on different types of storage backends that you have, you can set that here. You can import an image. If this was a new VM and you were going to bring a QCloud2 image, like a CentOS, a Linux image, you could do that here and point it to that URL. If you have an existing one, you can import it from the registry, or you can clone an existing one. So we'll just clone an existing one we have in the environment. You can add multiple disks at that time too. We can choose the instance types like we did earlier, or specifically choose how many we want. Now this is the networking section. By default, the first network, the first NIC on the environment will be the pod network, what's associated to it. We have advanced networking available, so we use Multis to add additional networks. So if you wanted to run OVS, DVDK, or SRIOV, or just an additional network, you'd add that on the back end, and those network attachment definitions would show up here, and they'd show up as additional NICs. The second requirement in the live migrate is you have 2 options for this. For binding mode for pod network, it's masquerade and bridge. By default, it's set to masquerade, and you need it that way to live migrate. If you set it to bridge, it won't live migrate. At this point, if you had a configuration script to run, you could run this at this time. If you had, like, say, if you wanted to run some sort of shell script at the beginning to add SSH keys, or you wanted to add user counts, this is where you'd run it. You can put that here. You have the advanced configuration, the YAML or the manifest. This is what it looks like. This is editable if you wanted to add additional options here. Click next. It's a finalized review, and then create, and it's completed at that point.
Yeah, great presentation. Really cool demo. Thank you so much, Chris. We've got some great questions coming in here. First question I want to ask you is, can Kubernetes really handle performance like tier 1 critical applications and workloads?
Yeah, absolutely. The host pass through that we have, if you wanted to, if you're running a GPU in that environment, you can do the host pass through. We can do CPU pinning. We have the advanced networking capability. So if you need low latency, high speed connectivity, we can connect SRIOV or OVS DPDK. We have all the different network configurations that we can add to that, and we do see performance benefits in the environment. We have a customer that when they moved over to KubeVirt, their throughput went 3x up based on that same configuration as a cloud stack environment.
Really? Wow, that's awesome. And I mean, you pointed out that this is based on KVM, and like you said, KVM runs the internet. So, and then what about operating system support? I that's another common question here when we talk about KVM. What operating systems are supported?
Yeah, so any of the Linux OSs, obviously, a couple of these you can see on my screen are CentOS that I've deployed. It will do Windows as well, so it supports Linux and Windows deployments.
Nice. And then what's the ideal use case for this? What are the most common, customers using this for?
So it kind of comes in this order: is if obviously the first need is what we talked. There's a need to modernize the environment, and so you have that in different forms. You have an enterprise environment where they have a bunch of legacy applications that may just die on the vine, and they're going to continue to just live in the environment till they just kind of fade away. We see that a lot, and so they will probably never be containerized. So they need a way to keep that virtualization in the environment, but still move to cloud native. Uh, or the other option is that maybe it's a third party application that isn't supported on containerization. Not like they're not going to offer that. It only comes virtualization because of the licensing mode, or it just hasn't been created yet. So they need to have that third party application up, and they still have a cloud native initiative to move forward. Or you have a company that maybe they're just going all in. Everything can be converted over to cloud native, but they need time, right? So that as they're migrating over, they'd like to take advantage of running Kubernetes and running that single stack and still have the time. So they're already running those VMs in Kubernetes, and it gives them time to break that up, right, and get into a containerized environment, cloud native environment.
Absolutely. And I mean, you bring up a lot of great points there. I mean, what's the real biggest benefits, like top three benefits to running KubeVirt on Platform 9 specifically?
Oh, so single stack, the complexity in the environment. So no longer you have to have a stack for virtualization and a stack for containerization. Single unified stack with a central control plane that's easy to use with Platform 9. As you saw in here, it's very intuitive. The Platform 9 support is second to none. So if something happens and it goes bump in the night at 2 a.m., and if you did it DIY, you're the only person that can do that, or maybe one other person. We have a whole team of industry experts that can jump in because it is SaaS based. We already have access to logs, and we're already a step ahead in troubleshooting your environment. So that helps. And last but not least, it's just so easy to use and kind of get you a step closer to that kind of cloud native and modernization of your infrastructure.
Excellent. Excellent. All right. Well, we're starting to run out of time here. So, a final question for you, Chris. What should folks do to get started?
Oh, great question. So if they go to Platform 9, they can go search for solutions and VMs on Kubernetes. Uh, you can kind of read more about KubeVirt, and you can click a button and talk to one of our experts. It might even be me, and kind of get you set up and see what your environment is and how we can solve your problems. And platform9.com/docs will give you kind of the full documentation information on it as well.
Excellent. All right. Well, this has been really educational, really fascinating. I know that this solution could help so many companies out there. Thanks so much for the excellent presentation and the awesome demo. Thank you to Chris, and of course, thank you to Platform 9 for making this event possible. For more information, visit platform9.com and have a great day. Bye bye.